Hi guys, this is Ms. Raina, your trusty physics teacher, coming to you once again from C347 here at MacArthur High School. Talking to you today, starting with the different types of forces. Take the opportunity, if you want to right now, to go ahead and pause the video right here so that at the very top of your page entitled Guided Notes: Forces, you can write down the 5 types of forces and their properties. So let's get into a couple more details. Finally got this sucker going, so let's get back into it. So for normal force, how do you define that? Well, it's basically the support force, and it is always perpendicular to the object that is doing the supporting. So like in this case, pretend this is a table, might be the floor, it might be your hand, but if some object is supporting another mass, then the normal force is going to be exactly perpendicular to that plane. That's what the word normal means. On level surfaces, so if the surface is not a ramp, then the normal force pushing straight up is going to be exactly equal and opposite to the force of weight pushing straight down. So then, what is mass? Let's have a look at distinguishing the difference between mass and weight. So mass, as far as high school physics is concerned, is a measure of how much matter an object contains. It's one of the factors in telling how much of a gravitational pull you will be able to exert as your own mass on another object, and vice versa, another object will be able to exert on you. So matter is, I don't know, the atoms, the molecules, the stuff that objects are composed of. So if you take a little rock from one spot to another spot, it doesn't change its mass. If I take a rock from Earth and I go and place it on the moon, its force of weight is definitely going to be different, but I did not change how much matter the little rock contained, and so I did not change its mass. Mass does not change when you leave Earth. Your weight does. All right, so we're going to do a little bit of practice finding weight and mass. So what's weight? Weight is a force. It's, every time you see the word weight, I want you to think in your head force of weight, and it results from multiplying mass times acceleration due to gravity. What's mass? It's the amount of stuff that an object is made of. So there's the force of weight, there's the mass, related things, but they're definitely two different things. All right. Which is changeable. I can increase or decrease the acceleration. I can increase or decrease the amount of force I apply. The mass, in general, doesn't really increase or decrease unless you take some boxes, for example, like off the cart or something like that. All right, so here's how you calculate weight. Normally in my notation, this is a little f sub w, but it's okay. It's still a mass times an acceleration. The difference is this is mass times acceleration due to gravity. So we'll have kilograms times meters per second squared, also known as a Newton. Either one of these formats is correct, but you need to understand very clearly that only kilogram meter per second can be abbreviated as a big N, as a Newton. So you can find your mass and your weight. First, take your mass in pounds, and you can divide it by 2.2 to get your mass in kilograms. And then all you've got to do is multiply by acceleration due to gravity. So go ahead and do that on your paper, and we'll check it all together in class. What's your mass on Mars? Well, it's going to be the same. Right? If I pick you up and take you to Mars, it doesn't necessarily change the amount of stuff that you are made of, but your weight is going to change. Why is your weight going to change? Because the acceleration due to gravity is going to be different there. It's less than half, only about 38% of what acceleration due to gravity is on Earth. So take a moment and calculate your force of weight on Mars, and we'll check it when we get back to class. Okay. So what's the actual effect of having different masses and different weights? Because we all know that apart from air drag, we're going to fall at the exact same rate when we fall down on the Earth because we accelerate due to gravity. The difference is we don't hit the ground with the same force. If a sumo wrestler falls next to me, he's going to apply a lot more force on the ground than I will. Here's a big rock, here's a little rock. They will fall with the exact same acceleration due to gravity. But this one will hit with a whole heck of a lot more force than the little rock will. Okay, so can more than one force act on an object? Well, yeah. You guys do it all the time. You're sitting right now in your chair and your force of weight is pressing down on the chair and the chair's normal force is pressing up on you. How do you know the total? Well, you can add up force vectors. So let's see how to do that. The net force usually has to be determined so we can tell what is the actual acceleration being done on the mass. Acceleration only happens if there is a non-zero net force. In other words, if all the forces are canceling each other out, nothing's going to accelerate. Remember, an object in motion stays in motion, or an object at rest stays at rest unless acted upon by an unbalanced force. That means there's some force that quote-unquote won and is pulling the object or pushing it one way or the other. If the force is balanced, it means the forces canceled each other out. There's no net acceleration. So here's one example, two forces going in the same direction, definitely an unbalanced force. So we add them up, we get our total. Here's another example, and they don't show you the vectors in the picture, but they show them down here. Think about it. This has got to be the force due to weight. This has got to be the force due to the normal force, the floor is holding up the box. Well, they're exactly equal and opposite each other, so they cancel each other out. So then here's a next time question, and we're going to tackle friction next time. If we need an unbalanced force to accelerate and we need an unbalanced force to decelerate, then how come every day objects slow down and they become motionless? They stop. And it looks like there's no outside force. So think about that for next time. I'll see you in class. Meanwhile, write down any questions you have, and we'll go over them next time I see you. Good luck, everybody.